All right. Okay. Push the button. Oh, that's not the right button. Yeah, nope, still not the right button. There's the right button. All right. Good morning, or afternoon, or evening, everybody. It is May 1st, 2017, on a Monday. And we're going to get started like normal. If you have any questions, anything I can try to help with, feel free to ask. I will do my best. If not, we'll be working on whatever current project. For today, I'm just going to quickly cover... Okay, let's try it again. I'm going to quickly cover what I worked on the MMO project over the weekend, if I can convince my microphone on the headset to stop attacking me. And then we're actually going to work on something that was brought up on Friday, try to do kind of like a little bit of a seeker thingy. I think it was for 8-Shot. 8-Shot, were you the one who was having the issue with the move to component and things like that? Because if you were, I actually think that would be a fun little project. I'm going to work on it today. Try to show how to do something kind of like a little bit of a seeker bomb and do it in both the generic version using line traces and then a AI version. Okay, yep. So I'm going to go ahead and do that today because I thought it would be fun and it'd be... I like doing fun stuff every so often. So I think it'd be fun to try to go ahead and recreate kind of like a little seeker bomb. So that'll be the project for today besides other stuff. So on the weekend, I worked on the project a little bit. I tried to work on getting some art working properly, learning animations and such. So I brought in our basic character from the Infinity Blades, and I realized that all of the Infinity Blade warrior assets, they're all warriors. They're all like armored men except for the one half-naked dude. So it's going to be a pain in the butt to get something that at least looks decent, but I figured I'd play with it anyways. So anyways, I got it moved over. One of the issues with the Infinity Blade assets is they were half completed. So the warrior itself had the character but no animations. None of the characters actually had any animations. So what I did was I used the existing animations that come with the mannequin, and then I pulled in a couple animations from like the troll to try to make something work. And then I learned how to do a montage, and I updated our character animation blueprint. So our character is actually, moving decently. I made it where when we attack, it turns on our auto attack indicator. So now that's working properly. And I put in a basic range check. So now I actually have to be near the enemy to attack. And we can see on the server, target not in range. So I spent a little bit of time trying to clean some stuff up. So now if I actually pull this monster, so let's target him, get him to aggro us. Bring him over here. When I hit attack and it's within range, I'll actually start doing an attack animation. And you can see him swinging like that. Now, I don't have it synced up properly because, we're using crappy animation. Not crap. We're using animations that aren't fit for our stuff. So I'm basically just trying to get something to work. The cool part is I also learned how to do the animation layer blending. So if we can get close enough to attack. There we go. Oh, I got all three of them. Well, I can actually start attacking and move at the same time, and you'll notice that just the upper torso moves on the attack, and the bottom will still maintain running. So I learned layer blending, which I had never done before. And then I set up where the monster dies, it properly gives out loot, and it plays for some fun stuff. Because the normal animation, just so we can wrap this up, for our melee is actually this. And you notice that the feet move and the legs plant themselves and things like that. But when you're moving, you kind of can't do that because then you end up with out of sync animation. So I just cleaned up some things. I thought it was fun. That's what I worked on. We'll open up the playground. I've got some questions, so let's see about that. 8-Shot. We'll be going over any of 4.16. I've only spent a little bit with 4.16. If no one has seen it, let's find it. UE4 Trello. I'm actually going through all this stuff to try to get a little more information. So the Epic changed their public roadmap. And they changed it to remove a lot of stuff that they didn't have anymore and to clean it up. But the cool part is they're actually putting in examples now for stuff that's coming into the new releases. So you can actually see here Instead of just saying, you know, runtime permissions on Android, they actually have a picture and they show them and they give more information. But the cool part is you even get stuff like this where they tell you about the rigid body animation node, you get an example of it and what it looks like. So I've been going through stuff like this. So more than likely, no 4.16 today. More than likely, 4.16 is Wednesday. I've got some other stuff I wanted to do today. I wanted to do that little other fun project. Let's see. Having problems with building lighting. The trees I have in my scene have a weird green color after building. What could be happening? Honestly, Zelati, I don't know. I don't play with... honestly, I don't ever use lighting. I don't make big enough projects where I need static lighting. I've never really used it before. I always use dynamic lighting. I just don't have a big enough project that I needed it. I'm assuming this is static lighting. Trees in your scene have a weird green color after building. About the only thing I can think of is you have global illumination turned on, or the light bleeding from like an emissive turned on. So that way the items are, once they bake, it takes the light that's being emitted and it applies it to other materials around it. I'd have to see a screenshot to try to take a guess, but that's the only thing I can think of. Pandora, have you ever attempted to implement Ryan Bruck's volumetric clouds? I have never attempted to do clouds, volumetric or not. I'm not an artist. I wouldn't even know where to start with that. So no, I have not, Pandora. Maybe in the beginning, you quickly explain it's possible to dynamically set object types for a line trace for object, and to set the mesh in an add-stack mesh component dynamically too. Okay, so let's see. Let me make a new folder here, and this will be Seeker Grenade, and then we'll see if we can help Schlump out with that one. So I got to try to understand it first. So we want that one, and we want that one. Copy this over here. This will be our Seeker character. And our Seeker game mode. We'll make a new level. And we'll save that out. And we'll call it Seeker map. Okay. So his question is... possible to dynamically set object types for a line trace for object nodes. So let's pull up our default character. Let's nuke everything we have in here because it's all old stuff I don't need. Let me clear. I really need to clean up my default at some point, and I say that every time, but I haven't done it yet because I haven't. Okay, there we go. So you're talking about a line trace for objects node. So this is a line trace for object node, and you're talking about dynamically set object types. So I don't see why not, because this is just an array, and the things that go into the array are what you put in there. So there's no reason, for example, you couldn't have promote to variable, and this would be, for example, you know, objects to trace for, and by default it's going to be empty. And then at a different point in here, you could have your objects to trace for, and then you add to that, and you add your world static. Anything you add is going to go into it before you do it in here. So you could have, you know, all you have to do is fill out this dynamically, and then it'll search for it. So however you want to fill it out is how you would create a dynamically set the object types. This is just an array. It holds a bunch of stuff. The stuff can be added at any point you want, and also be removed at any point in time you want. So you can remove and add them at any time you want. So you would just, you know, loop through all of them and add them if needed, or add them as needed, whatever you want, as long as you fill out your array. The question, driver fiction, do you prefer Blueprints or C++? I prefer Blueprints. I do not want to use C++, and I don't use C++ for Unreal Engine because Blueprints make programming fun. 8shot, you want to make some assets? I'm a 3D artist, so I could probably put something together. Thank you for the offer, 8shot. If we do get to that point, I'll be more than happy to take you up on the offer. Right now, my goal is just to get our test stuff working with all public stuff, so that way anyone can recreate this And once I'm done, I can freely give it out to any other Unreal Engine licensee. Second question for Schlumpf. Set the mesh in an add static mesh component dynamically. Well, add static mesh component. Now we want to set the static mesh dynamically. That is a good question. I don't think you can, but my guess is you could change it later. Like right now, we would add nothing, and then once we get this, we should be able to set the mesh right here, and then you can change the mesh to whatever you want. So you would not be able to add it dynamically because once this node runs, it uses all the existing stuff. But after you've created it, you have a reference to it, so then you can set your dynamic mesh, and this can be anything. This is dynamic, so feed in any mesh you want. You know, you could have something like a branch statement here, and you could have, you know, we'll promote this to a variable. You know, we'll get rid of the old one, and this one's the, you know, static mesh to add. And all we have to do here, we could do something like, oops, probably easier to do. Something like here. I'm just actually no, because this would be fine. I'm just randomly trying to hook stuff up like this. So let's see, stack mesh add, set. This is just a rough example of what you could do. So let's say when it was true, you want it to be a cube, and when it was false, you want it to be a I don't know, a cone. So you could set it up like this. And this would basically come into your branch, change the stack mesh to add to whatever mesh you want it to be, add the stack mesh component to our blueprint, and then set the stack mesh that we just created to the one we set right here. So that would be the easiest way you can do that. That's how you would dynamically do it. You wouldn't do it during the creation because you can't change it during creation. But afterwards, you have a reference, and you can set the stack mesh on that reference. So that's would be how you would do that. Let's see. Zilati has stuff here for Answer Hub. So let's see if we can pull up Answer Hub and see if we have any information. I doubt I can help you on this one. I'm not an artist. I fake it very poorly. Let's see if we can get this to pop up. Assuming Answer Hub wants to cooperate. Which almost never does. There we go. Okay, rainforest, build a line, trees turn to a weird green color. Are we talking, so that looks weird to you? I mean, it looks like lighting to me, honestly. This looks like it's getting lighting. I mean, because that looks, let's see if we can make this bigger. Of course not. I mean, it looks like we have shadowing here, and it looks like this is light. All it looks like is this is light to me. Like you have a light source coming in, and it's, I mean, because you have light, this looks like light. This one being green, I'm assuming that this green, this is the same material on each tree, maybe, is what you're thinking? Because this looks like maybe it's just the wrong material being applied. I'd have to maybe see the material node. Because, I mean, nothing looked wrong with that one in terms of, unless that, well, obviously that wasn't your expected result. You know, these things look like they're just light. It looks like it's reflecting light off of something. Which could be the material. It could be the angle they're set at. Your material might be doing something with things at a certain angle. I mean, that's about the only thing I could think of. Maybe if you have the material, we could try to recreate it. Also, do you have like your leaves set to two-sided foliage or one-sided foliage? I don't think I have an answer. The best I could do is maybe look at the material and take some educated guesses. When you leave Unreal to another engine, what are you going to do? I can, okay, so Diver's question was, when you leave Unreal to another engine, what are you going to do? I'm going to use whatever I need in whatever engine. Unreal offers blueprints, C#, JavaScript, C++, Skookum script. I think there might even be Lua, so I mean I could do it in any of those. I prefer blueprints. When I'm working in Unity, I prefer C++, C#. When I'm in general coding for businesses, I prefer C#. So, I mean, I have other options. It's just in Unreal, I choose Blueprints because I use Unreal for fun. Loki, I was wondering if you or anyone else would know how to make a gun shoot like in CSGO. How the bullets always go in a certain location. Have the same recoil every time. That sounds like it's just a line trace. If you're talking about them always shooting straight. Is that, I mean, are you trying to basically simulate my character fires straight and it hits the target at the same point every time? Because that's just a line trace. And if you have any form of offset to the line trace, then you end up getting the same result if you use the same offset. If that's the question. Yeah, maybe if you either have an example of what you're expecting, or if that's what it is, then it's just a simple line trace based on what you're saying. The line trace is generally used whenever you fire. You don't use physics or velocity or anything like that. You just say, hey, fire a line straight, hit something, the bullet shows up there, boom. It's a line trace. It's traditionally used for projectiles. So we're going to make this a actor. This would be blueprint, seeker mind. And and we are going to set up our mind as our default. Is what we're going to do. I'm pretty sure that's going to be too big, but we'll figure it out in a second. Let's also give it a material for fun. Let's see. Can we do this? No, you got to do it the other way. You got to assign it the other way. Okay. So, match seeker mine. And blah, blah, blah. We'll just make something really simple. Let's make it a white mine, and I like green for emissive, and I think that'll work, right? Let's see. Seeker mine. I think that'll work for now. It's way too big, but I'm not worried about that. Okay, so let's nuke our floor. Let's add in some terrain. And I'm not very good at terrain, so this is going to be fun. I only need one section, right? It should be big enough? Yeah, it should be big enough. Let's, I can't remember the hotkey to make that smaller, so that's not going to help. Yeah, we'll do that. We'll go blue and blue. Let's just throw some little hills and some ridges and stuff like that to give it some sort of terrain that we're gonna test over. That is our point here. Okay, so that'll work. Blah. I don't have a material assigned to it, so that doesn't help. I don't think I have any grass material in here. I have a glass material. I think I tried doing terrain at one point. I might have terrain material in here. Let's see. Oh, I can just go to our root and I can tell it to give me all the materials. Okay, we have a bush. That doesn't help. Oh, there's some ground. There's some ground grass. There's some ground moss. This stuff would work good if I knew how to use the terrain node properly, which I don't. But we can, should be able to just give it grass, right? I don't use terrains very often, in case no one can tell. Let's get, can I not have that? Oh, it's compiling the shaders. Okay, so that'll work. That's better than nothing. Okay, so let's pop our character out. Let's put him right here. We're gonna put him right there. We'll hit play. Okay, so there's our base. Cool, we got something. Let's see. Recoil pattern. When you yeah, Z-Lottie, when you set the foliage to movable, that means you're not going to get static lighting. That means built lighting will not affect it. So that makes sense. It only happens when you build lighting. Makes sense. It happens because of bounce lights. That kind of makes sense as well. As you continue to hold fire, the bullets start piling up, pulling up. Oh, and they have some variants. So that's just we did something with that. We kind of did something with that. We did. Okay, so let me jump over to that then right now. We did something very similar to that. Someone asked about crosshair variants. And we did something very similar with that with crosshair variants. Let's see if, okay, so let's get it working. There we go. I also think I have these things set to, hold on a second, let me turn debug mode back on. That would probably help. Let's see, persistent, oh, duration will work, that'll work fine. And then, yeah, okay, so this is our persistent one. Hold on a second, so let's try this. Let's see if I got my bullets. Nope, of course I don't, because what do I have this? Oh, because I'm only set to go to the pawn. Let me fix this. I think world static work now, because we were testing where it only works. Okay, so here we go. And there's a, okay, this one's set up. This is not our variance one, so we need to hook up this one. Okay, there we go. I think this is set up for our variance now. Okay, so we can see here where we set up the basics of when we're firing. We have our little bit of a spread. Let me make our spread smaller. Give me a second. There we go. So we have a smaller spread, as you can see here. Now, this is a randomized spread based on movement, is what it is. The more we move the cursor, the more the more we add to our inaccuracy variable right here. So you could, whenever you fire, so in this case we fire a bullet, we could set it where the inaccuracy goes up every time we fire the bullet. So let me switch what we currently are showing in here. So here's our input, and this is where our inaccuracy gets adjusted. So we're going to go ahead and just disconnect this. We're going to plug this into here. This should be a quick basic example if I'm right. Okay, our number's not changing, that's what I was checking. And as you can see, our accuracy is 100% because we're firing straight. And unless we move, we shouldn't have any variance. Now, if we go to our node when we fire, which is right here, so we fire, we do our line trace, and we fire out where we're going to hit, and it says fire a bullet. I also have my tick event, which I'm printing something somewhere that is causing some horrible, horrible issues here. Give me a sec. Where's it at? I think this will do it. Okay. If we go in here and every time we pull the fire button, we add to our inaccuracy. So, for example, current inaccuracy, we'll set it. We'll grab the current inaccuracy and we'll add. Oh, we'll add 1. Why not? And we'll do this. This means that our bullets are going to get inaccurate over time as we fire more. So if this is right, the more I fire without moving my cursor, you notice the bullets are starting to get more and more inaccurate. And you'll see that number in the middle. It says 45, 50, 55. That's our inaccuracy. So if like I held it down, this is every time I fire. So you do this on your rapid fire. And right now my inaccuracies are adding to both the Y and the Z. So the left, right, and the up, down. If you want to only affect the Z, for example, we could disconnect that and tell it to not add to the Y. And then we could tell it if we only want it to go up, for example, then we could set our min at like 0. So now it's only going to go between 0 and max whenever we fire. Or you just add the current inaccuracy to the Z. That's probably the smarter way of doing it. So in theory, if I did this right and we start firing, whoops, I gotta stop moving my mouse. You'll notice the line trace going up automatically. You notice the number on the left going up, and you'll notice the line trace going up as well, because we're adding an inaccuracy. So that's your basic theory then. You have, every time you fire, you give yourself a little bit of inaccuracy. So this is an auto fire, this is manual fire, whatever it is. You're just giving yourself a little bit of an inaccuracy because you're firing. And then you adjust your line trace by that inaccuracy on whichever direction you want. In this case, the Z. We only want to go between 0 and our max inaccuracy for going up. if we're doing it random. If we're doing it fixed, this means every time we fire, we're going to get a little bit more inaccurate, and we're going to raise our sights. Our gun is basically going to kick back a little bit every time. We're adding to our Z on our line trace. And that's how it would work. And then if you want it to go down, then you would just do something on your tick, for example. And in this case, we could grab, this is the number right here. And we could do this. And this is basically going to say on our tick, or whenever you're not firing or something like that, we want to subtract a little bit. So in this case, I'm going to subtract a 1/10 every tick, which is probably still not enough. Well, probably enough. We're going to go ahead and subtract a 1/10, and we're actually going to change our kickback to be much larger. We're going to change it to be 5. So it's much more noticeable. Now, that number, if we fire, you'll notice it going up a lot. And if I stop firing, you'll notice our number goes down, so our inaccuracy goes back. You'll notice I'm firing again towards the middle. The more I fire, the higher it kicks back. I run out of ammo, it reloads, our inaccuracy goes back down, we start firing again, it's going to come back to the middle. So you'd adjust your numbers appropriately based on the results you want. And of course, these are variables, so you can change them to whatever you want. So yeah, so your basics, just to wrap it up, is every time you fire a bullet, give yourself a little bit of an inaccuracy. Every time you do a line trace, add the inaccuracy to your destination on your line trace. Every tick, or even on a timer or whatever you want, subtract a little bit of inaccuracy. So that way, every time you're firing, you're becoming more and more inaccurate. Every time you're not firing, it's going to go down, and it's going to eventually get back to where you're accurate again. So that's probably the easiest way of doing that. And you can have each gun react differently. For example, in the Division, you have both horizontal and vertical accuracy. And that basically adjusts how much jitter you get right here. So if your gun's really accurate on horizontal and vertical, it's only going to add a little bit. If it's really accurate on the vertical, for example, but not the horizontal, then you're going to get much more on your horizontal for the left and right spread. And they do that on a per gun basis. And it's all basically the same thing. The more you fire, the more inaccurate it gets. The less you fire, the more accurate it gets. Let's see. You haven't missed much, Akash. We're just explaining some stuff. Any videos for people to start because that looks so complicated as C++? Do you mean a video for learning Unreal? Or do you mean a video for learning Blueprint or a video for learning C++? That would be the question on that one. ArchViz is architectural visualization. Think of it as making a complete 3D representation of an environment as good looking as possible, and it's meant to represent the final result. Useful for, we're building a new office and we want to see what it looks like, so they do an ArchViz representation of it. 8shot basically summarized it. It's where an architect goes to a 3D artist and asks, hey, what will it look like when it's done? How difficult is it to implement changes in gravity direction in Unreal for things like walking on walls? It's 100% difficult to change gravity direction in Unreal. Unreal is Z-based gravity. However, if you don't use gravity, you can do whatever you want. You could simply have a line trace in a certain direction, look for walls, and then have your character move in that direction. It's kind of like what we'll be doing today. For example, our item is going to look down, and it's going to look at the ground, and it's going to try to move itself to a certain location from the ground. There's no reason we couldn't have it look up, for example, and move itself to a certain location up. You'd basically fake your gravity and have your character drawn to a certain direction. Let's see. Blueprints and Unreal Engine. Not really looking at C++. Okay, so there's two things I'd recommend. Actually, there's a couple. Let's. This is probably a good one that most people don't know about. This is Tom Lumen's Zeef. Tom Lumen's someone who's worked with Unreal Engine for a while. He got a Zeef, so I'll put the link in here. And it's basically a collection of stuff, of links. So you have things like Learning Unreal, and here is topics, tutorials for learning Unreal, and it gives you, stop, you stupid pop-up. The pop-up won't go away. Okay, so it's got things like, you know, the Getting Started guide, the YouTube official channel with playlists and other people, courses on learning blueprints, learning C++, plugins, individual stuff such as UI, AI, third-party tools, landscape. So this is a good central location. So YouTube is a definite official one I would recommend. If you go to YouTube's official channel, Unreal Engine, and go to their playlist, they have an intro to series in here. Getting started with UE4, intro to the editor, intro to blueprints. You can make a introductory game, introduction to multiplayer, intro to materials, level creation, paper 2D, and inventory. So they have a bunch of beginner getting started with stuff. So that's where I would start with. Okay. I saw a video of a guy making two objects attract each other by changing gravity. I didn't watch the whole video, but I think it's possible. Well, as far as I know, well, okay, let me rephrase this. By default, out of the box, gravity itself, if we're talking gravity in physics, it is a Z-based system. Yeah, you can have things attract each other, but it would be a Z-based system. And we're talking about, when I say physics-based, I mean things like our capsule cone, things like our physics, things like enable gravity. These are all Z-based. Now, you can either use a custom fork of the engine, which has gravity that's not restricted to the Z, or you could fake the gravity. You literally don't use the built-in physics system, and you say, hey, this item's here, everything around it, give it a little bit of a force, and everything around here, give it a little bit of force, and you can have things naturally attract. So, you know, you have two circles, you have a certain radius, you can say anything within that radius, tell it to go this direction, and you fake forces. Yes, unfortunately, in Unity, gravity can be set to pretty much anything you want in Unity. It is unfortunately a limitation in Unreal Engine that they have designed it to be Z-based. It is something they are working on. It is a known, and it's something that's been requested a lot. Unfortunately, they just don't have it yet. Let's see. Walkthrough of adding gravity in UE4 for any direction for an actor. Okay, so let's see. So you'll notice a couple things in here. Well, I can't really say that. So let's see. I'm just trying to jump through and figure stuff out. So look at rotation, get forward vector, probably adding impulses. See, he's not, I'm trying to find, I wish I had, yeah, there's the gravity parent, that doesn't help. Yeah, it doesn't help that we can't easily see some of this stuff. Well, because you'll see right there, for example, on, the items he brought in as soon as it goes back. Okay, so these are the new items that he has in, right? Okay, so those ones are fine. Okay, it looks like you fixed it. Yeah, so he's got custom code in there to basically make things go in a certain direction. He may not even have gravity enabled. He may just have simulate physics turned on. I can't see down here. He may just be not using the built-in gravity system. He may be using physics and just faking his gravity system. That would be my best guess. Like I said, that's one of the options you can do. I'm just scanning through it. I'll probably take a look at this later. This right here, though, this requires math, and the math breaks my brain. Which is always one of those things. Because he's adding impulses, he's setting velocities in the correct vectors. Yeah, we'll just quickly finish this up. See, like these ones, I'm pretty sure have gravity enabled. Those square blocks, because they look like they have normal gravity enabled. I'll check this one out later. My guess is he... Oh, no, see that one's... Yeah, so I don't know. That's the biggest thing. My guess is he is either overriding the gravity or applying it himself. But by default, yeah, it's a Z-based gravity system, unfortunately. Don't know if you know this. If you use a size box in UMG, will it scale to the game resolution being used, or is it locked? It depends on your settings for your scale. So inside of our widgets, let's find ourselves a widget. There's a widget. Let's see if we can find it. This one's always a pain. Oh, actually, it's inside the project settings. Hold on a second. Of course, I gotta find it now. Of course, I've got to find it, and I don't know where it's at. No, maybe just user interface. There we go. So your user interface has what are known as DPI curves, and this determines how much things scale. So you notice down here, everything up to like, what do we got? 1080. So 1080 is designed to be a scale of 1. So anything with your, I want to say it's a horizontal resolution of 1080 is going to be exactly what you tell it to be. Anything less starts scaling the result, and anything more starts scaling. So it's a linear scale. So technically, it'll look fine on the higher resolutions. It'll be roughly the same size because it's scaled. So if you have more on the vertical, it's going to end up being scaled. This is the way they handled screen independence. So you design it around a 1080 screen, and then everything should go appropriately, assuming you have this turned on. And by default, this is turned on. So to answer your question, the scale box will technically scale itself to the resolution, assuming this is turned on. And this is by default. Yeah, this is hidden. It's just annoying. It's under user interface. That's your default scale. It has different settings. Like, for example, if you were programming for mobile, you might want to change some of these things. If you're going to have like a vertical resolution instead of a horizontal resolution, you can change these things. So you can see shortest side, longest, horizontal, vertical, and custom. You can make your own scaling curves depending on what you're programming for. You can even change it by default if you just want to make it bigger or smaller. And I want to say if you are in your widget, that's what these options are for here. And you can set your different screen sizes. So like grab a different screen size and then tell it to do something like desired or desired on screen. And it'll actually show you what things look like when they're scaled rather than what they look like naturally, instead of just like fill screen and things like that. There's lots of options. Okay. What are the consequences of using fake gravity? Are there collision problems or something? I don't think there are, as long as you've got to keep in mind, gravity is just intended to like be a consistent force that's pulling in a direction. You can still use the physics system and fake gravity by giving impulses and velocity and things like that. As long as you're using the physics system, your collisions will work fine. If you're faking gravity by moving something, for example, then you might have an issue. So that's kind of a problem. But even then, your collision problems may be not an issue because you could do line trace collision and you could do basically manually handle the collision. If you're going to rip out and use if you're not going to use the physics system, you're going to have to handle collision a different way. That's just how it is. Collision's not going to work without physics because that's the way it works. It would be nice if there was a way around that, but I don't think there is. I mean, technically, you just have to roll your own like line trace system. And hello to everyone who has shown up recently. Okay, so let's see. We've got a basic material here. And let's see if we can quickly make something that will stay off the ground. That's kind of what I want to do in the beginning. So we'll do it on tick. And we will just, let's see how simple we can do this. We'll do a line trace by channel. We'll do visibility. We're going to grab get actor locations. We're going to grab our location and set that as the start. And then we're going to get up vector, down vector. Which friggin' vector is it? Oh no, I need to grab the I need to grab the actor itself. So yeah, right? Hold on a second. No, get up vector. See, apparently I can't spell it right. So we want to grab the up vector. Let's see. So get actor get, oh, we'll do it the other way, that's right. Get actor rotation. It's been a while since I've tried something like this. So this will give us which way is up, and then we'll multiply that by -1. It should give us which way is down. And this will just give us the direction that's down, and then we multiply that by 400, and it'll give us down 400. And then we add that to our starting point, and this should give us an endpoint that's down 400. And if I did that right, it should be fine. So let's see, let's load our map back up. And let's see if we did that right. We'll pull him up a little bit, and we'll hit play. There we go. So that tells us which way is down. So we can easily do something like, let's see, if we hit something, then we're going to break our hit result, and we're going to get our hit location right here. So let's do set actor location, and we're going to grab our hit result, and we're going to add to that. So impact location, and let's see, how big is our item, our sphere? I don't know, because it's a sphere. That doesn't really help. Let's assume it's 50 up, and we'll see how that works out. So we're going to add 75. So impact location, add, let's see, we're going to add to the vector. We're going to add 75 on the Z, set that as our new location. Let's see what happens. Okay, there we go. So that is going to set it to 75 off the ground every single frame, is what that's going to do. So in theory, if this worked, then we should be able to let's set up a begin play, and let's do a move 2. I can't do an AI, and the simple move 2 isn't going to work without AI, so we're going to have to just lerp. Let's try that. Lerp 0 to 1, play from start. Let's see, let's add a float track, 0 to 1, add a key, set the first key, time 0, value 0. Second one, time, let's take 3 seconds to get to us, is what we're going to do. So over 3 seconds, we're going to try to get to our character. So we're going to, I should probably cache it, but in case a player moves, I'm not going to. So we're going to get the actor, get player character. I don't like doing that. I like get player controller, and then get control pawn, just because it feels better to me. There we go. And get actor location, and this will tell us where the actor is, and then we're going to set actor location of our sphere dude, and we're going to want to end up roughly here plus a little bit. No, I guess we'll go to the middle, will be fine. Yeah, that should work. But we're going to want to lerp, lerp vector, because we're going to go from where we currently are to where we want to go. So this is where we want to go. This is how much we want to go, and this is our current location. Like that. So in theory, something might happen. Whoa, holy crap. That seemed like it went way faster than 3 seconds, right? I'm not crazy here. I also apparently closed it, so that didn't help at all. It worked, but wow, that was fast. Someone did something horribly, horribly wrong here with our math. We're going to go from 0 to 1 over 3 seconds, and we're going to lerp from our current one to our end one. It shouldn't get to the end location till 3 seconds in. Did I do something wrong? No, right? Okay, let's change it to 5 seconds. I think I did something wrong, did I? Here, let's do 0.5 to be safe. Let's see what happens. This means it should always get... Okay. Well, first of all, that's really friggin' cool and annoying. But, apparently my lerp math is horribly wrong here. I have a feeling I need to cache the current location. That generally tends to be the issue when you do stuff like this. So let's do that. I have a feeling that's what it was. I didn't think I'd have to do it, but I probably had to. So let's promote the actor's current location when we start to the start location. And then we will lerp between the start location, which will stay fixed, to the end location. Okay, see? And it should actually end halfway to me because I never said it to go. Okay, cool. So now we can change this back to a 1. Bloop, bloop, like this. We'll change this back to, whoops, 1 and 3 seconds. Change our timeline to 3. And let's see now. Okay, and we definitely have an issue with our item not... Oh, so we have a problem with Z. I probably don't want to adjust the Z because we're setting this and we're setting this, and both of these are screwing with the Z, so we don't want to do that. So we want to split this, split this. Can I split that, please? Thank you. We just want to adjust the X and the Y. We want to make sure the Z is whoa, the crap, where'd the Z go? Oh, we don't want, oh crap, we don't want, we want the, what's the smartest way of doing this? I guess get the current location would probably be smartest. Basically get our current Z and feed it in. So we get where we want to go on the X and Y, and we get our current Z. There we go. So I want to make sure it was off the ground. Whoop, holy crap. That found us. Also, it doesn't help that my speed is still set to 1200. Okay, let's fix our speed. Where did I set that at? Oh, 5,000. It's 5,000, even worse. Okay. Wait, why did that not look... Oh. So, someone didn't set up the proper character to be used in here, so let's do that. There we go. And I'm sure someone didn't even set the proper game mode, because he probably forgot to do that. Yep. So let's fix that here. There we go. Now my guy won't... Oh, seriously? Still... Oh, man, are we not getting the right... No, secret character. Okay. And character movement is set... Whoa! Someone did 6,000 instead of 600. Gee, there we go. Now it's better. But yeah, this is just the basics of... It works with terrain. That's what counts. That was the goal that you were having an issue with. Pandora's. More than likely this is Final Fantasy VII. Yes, it is. Let's see. Are requesting how to do things, you figuring certain things out. Right now I'm doing something that I thought would be fun from Friday. You can feel free to request anything. Drag off the current location, do minus on the Z-axis. Yep. Let's see. What does lerp do? Lerp interpolates between one thing and another thing. And by interpolate, it means basically figures out something between the two things, if that makes sense. Which it probably doesn't, but it's easy enough to show in an actual example. So our simplest one is just a lerp float, which is our lerp. And let's say we're going to lerp between 0 and 1. Simple enough. We want something. This is why I use the word something, because lerp can work for vectors, locations, rotations, floats, blah, 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 blah. Anything can technically be lerped. It's great for colors. So for a lerp, basically we have an input, and we have two inputs, I guess. A minimum and a maximum, two values. It really doesn't matter. You have two things. And you want to know between those two things what another thing is. So our output value. And how you determine the value is how far along from the start to the end your thing is going to be. So in this case, it's 0.0. This is your 0. This is your 1. That's why I did it as 0.0 and 1. So if you plug in a 0 for your alpha, you're going to end up with as close to this as possible, 0. If you plug in a 1 for your alpha, you're going to end up with as close to this one as possible, or 1. And if you do the math, you basically end up with 0.5. So 0.5 is basically going to be halfway between this number and this number, which is 0.5. So that's what makes it super simple. And it works for any set of things you put in. 0 is how close to the top number. 1 is how close to the bottom number. So if let's say you had 0 to 100 and you had an alpha of 0.5, that means halfway between 0 and 1, because alphas are 0 to 1. So you're going to be halfway between A and B. You'll be 50. And the nice thing is it works for any numbers you want. You don't have to care about any of this stuff. You're just going to be 50% of the way between this number and this number. So when we're doing our lerp here, and lerps are good for smoothing is their primary use. So right here, basically we're saying over 3 seconds, I'm going to give you a value between 0 and 1. That's our little line here. So 1 second in, we have 33%. 2 seconds in, we have 66%. I don't know, we're at 0.64 seconds in, we're going to have 0.21 as our value. That's what's nice. You don't have to care about that. We're just going to output a straight line. So that's going to basically say, hey, between our current starting location, so where we started, and then where we want to end up at, based on how far along we are on our 0 to 3 seconds, we want to go ahead and give us the value for where we should be. So it allows us, as you can see here, go from start to finish smoothly, assuming it doesn't kill my player, which it did. And that's what's nice about it. So no matter what, because I have it set up to follow the character, it's going to keep following. Obviously, if I set it as like the fixed location, then it's not an issue. For this example, that's probably smarter, because you, well, I guess not. Like, for example, we'll just change this right here. We'll grab these. Actually, we'll just disconnect these. Move him over here, like this. Promote him to a variable, and this will be our end location. So we'll make it where our mind seeks, but doesn't follow. Do that. So start from our seeker bind, end at our player. Fill in our end location right here. And plug this in right here like that. This is going to say, hey, start at the start, end at the end, and do it over 3 seconds. That's what our lerp's going to let us do. Now if we run this, you'll see it smoothly go from start to end over 3 seconds. Bloop. And then we'd set it to blow up, and everyone would fly everywhere, and there'd be, you know, gibs and jibs and turkey legs and all that stuff everywhere. But that's probably the simplest way of doing this. And yeah, for 8-shot, this works, as you can see here. You basically would adjust your distance and your tick, because this is just simply saying, hey, go down, keep my character that far off the ground. If you wanted it closer, you'd adjust it based on the radius of your sphere and all that other funky stuff. But the nice part about that is you did notice that, like, I can move my character here. And let's move him. Let's move him. Let's move him right here, for example. And we've got a hill in the way, and no matter what, it's going to go over the hill and down the hill and never go through. So really simple. That's the simplest way to do like a seeker bind. Can you make the character joining a car? No animation. He just automatically joining a teleport. You can use the teleport button and teleport him into place. You're gonna have to make sure you put him in the appropriate pose, like you'd have an animation pose for sitting. So it shouldn't be that hard. You would basically trigger the door, the entering. You would use the teleport node, tell it to teleport the character inside there. You would set the animation to the current pose, which would be sitting or whatever. One thing you'll have to note, though, is your capsule collider and even your mesh. There's a possibility that they'll both collide and cause an issue, so you might have to disable your capsule collider on your character. Another way of doing it might be to simply hide your player or teleport your player somewhere else and spawn in a mesh inside of your car that shows your player. Just have a mesh that's hidden even and have it unhide, so that way you have a fake driver sitting in there. And once he's done, you hide the fake driver and you move your character or respawn your character back to wherever he's supposed to be when he exits. That's probably the easiest way. Then you don't have to worry about attaching and all that other stuff. I cannot make a tutorial like that really fast. I have none of that stuff set up. I have no sitting animations. I don't have any of that stuff. it would basically, I mean, if you want in terms of simple concept, see, I don't even have a car, so it's really not going to help, but you would just have, let's see, so let's do like a, again, this is going to be really basic. Let's see, so we have like this, which will be our car, which is going to be represented by a cube. And what do we got? 2, 3. And it looks car-like to me. So, you know, we have a car, and then we have a player, and then when our player gets next to the car, we would basically teleport the player in. A lerp. Okay, so let me answer the question. A lerp takes whatever you give it and gives you out. That's all a lerp does. A lerp is a math node. If we look at the, let's go back to the other one. Where'd it go? I don't remember what I called it. Seeker mine, right? So in this case, the lerp is a math node. This is the lerp node. This is where we're finding the location. This is where we're setting how far along we are in the lerp. The lerp itself is just a math node. Takes in stuff, outputs stuff. That's all the lerp node does. So in this case, we're taking in a starting and ending location, and we're outputting where we want to be between the two based on how far along we are. That's what it is. My set location is what was making it go smoothly. That was saying, hey, when we figure out what value we want to be at, go ahead and move there. And then it would continue looping. Move this up a little bit, like, you know, move it up a little bit, figure out where we're supposed to be, move there, move it up a little bit, figure out where we're supposed to be, move there, and repeat it over and over and over as our lerp, our timeline. Let's see. So, do car. Let's say we did a scene component, and I don't know. We're gonna put them up here because we can. This will be our seat. Here, let's see. Car, enter. I'm gonna have to make a new player. Where'd that car go? Oh, seriously? Oh man, did I not copy that? No. Try this again. Okay, I meant to delete it, but I guess that'll work. I mean, I meant to move it, but that'll work. Yep. Okay, there we go. Car enter. Third person. Blueprints. Car enter. Copy here. Let's see. Car character. Car game mode. Let's actually set up our game mode properly this time, like I forgot last time. Car character. Okay, and set our map for car game mode. This is just my pre-done. Okay, so now we have a character we can edit, which we kind of needed to. We can nuke all this stuff, nuke all this stuff. I'll make this really simple. I'll put an E key here. So I'd like to put an E key here if it'll let me. Can I have my E key, please? Thank you. Now get all actors. And what, you know, we'll do a sphere overlap. Actors, yeah, that'll work. And then we want car. And I don't know what my car is, but I guess we'll find out here in a second. Let's see, what is my car gonna be? What type is it? block all dynamic of world dynamic. Yeah, world dynamic works. So world dynamic. This should, in theory, give me my car if I did this right. To get actor locate, get actor location. Thank you. So we're gonna do a little sphere around our character. I don't need this stuff. This is all stuff I don't need. There we go. So we'll do a little sphere around our character. We'll grab the first car we get, and then we're going to cast. Oh, we already have. Well, this could be cars. No, it could be reference. Cast to car. Oh, great. Why is it showing me 2 cars? Probably because I have 2 cars in the friggin'. Well, that doesn't help. So we're going to have to rename this one. So this is going to be car enter. Which means I'm going to change this one to car enter. Cast to car enter. There we go. So that should grab the car. And then, what did I call it? Seat. Get seat. Just give me the seat in the world. And then, this is kind of an issue. And the okay, and then max was, and the move there just knows to go up and down depending on the mountains. No, there was 2 things that were working with that one. Sorry about that. This is just simply moving it along the X and the Y. This code right here was keeping it 75 units above the ground. We were doing a line trace, looking at the ground, adding 75 to the ground, and keeping our item 75 above. So that's what this code right here kept it above the ground every frame. This code right here moved it towards the player every frame. That's what these 2 things did. In sync. In sync? In sync. Ah, that's close enough. Oh, I have no idea how I'm going to do this. Because the problem is you have controllers and stuff, but I mean, this is just the basics. If we, for example, set actor location, this will set the actor's location to the world location. I mean, this is probably going to work out horribly, horribly wrong right here. Let's do it. Actually, let's do the teleport node. That's probably smarter. Like that. Okay, I have no clue what's about to happen, so I guess we're going to find out. There we go. So that's the basics of what we did there. We got up to it. I hit the E key. The E key fired off the code right here, which was basically find a car that's around us. All of this code, for the most part, it has to be customized to what you're doing. Like I said, this could be very generic. But all I did was find a car that's around us, and then find the seat location I put on the car, and then teleport my character to there. The problem is, at that point in time, technically you have the controller still there. I mean, you'd want to do something like... no, I want to unpossess the stupid... Seriously. Thank you. You'd want to do something roughly like this to start, because what this will do is I can no longer control my character. We don't have the controller, the player, basically on the keyboard controlling my character, so I can't do anything. I'm hitting keys and moving the mouse. At that point, if your car was an actual object that you could move around, you'd possess the car at that point in time. And then that basically puts your character at a certain spot, and then now you're controlling the car. And then when you're done, you could just do the opposite. Your car, for example, here's our car right here. That's where the seat is. There's nothing stopping you from adding another scene component. Scene components are just references to a location. And this could be like the exit. And you could put it right here, for example. So our seat's on the top and our exit here. So when you're done with the car, you just have your player teleport to the exit. And then that's where they'd end up. And then you'd repossess the character. I don't have a vehicle set up. We have no animations in place for this. So like my character's not sitting. This is just a super simple way of doing it. You might run into issues because if you notice, when I hit I told the character to teleport, we still have collisions enabled. We still have our character right here. He still has his capsule collider that could collide in the world and things like that. You'd want to do stuff like after actually probably before you teleport, you'd want to do something like grab our character here, and you could grab the capsule component. Or just grab the capsule component, make it easier. Okay, now at this point I'm moving stuff everywhere. Grab the capsule component, and you can set its collision enabled. Stop it. To no collision. And that'll disable the capsule component from now colliding with anything. So that would prevent the issue. But then you still have your mesh, which is set up with collision. So you probably have to disable that. And then you'd have to make sure that it just sits there if you put it as part of something else when something else moves. I mean, there's lots of things you'd have to do. So like you'll notice now our character's kind of in the vehicle now because we don't have our capsule component preventing it anymore. But he's falling because he has physics enabled. Well, he has character movement enabled, which means the game thinks he's falling now since he's not on the ground anymore. So you have that thing to worry about. I mean, there's a ton of things that you'd have to work on. The easiest way might be just simply hiding your character, spawning in or unhiding an existing thingy inside behind the wheel and going. Yeah, there's a lot of options on what you can and can't do. A game like GTA, simply because of the fact that you have animations for everything, they don't respawn. They probably just do whatever they need to do with collisions to make sure when the character gets in the vehicle, he doesn't collide. They play the animation for opening the door or whatever. They play the animation for getting in. That's all pre-done animations. It probably has either a little bit of IK or some form of attached points. Like, for example, you have the seat and you have the steering wheel and things like that. So the character would just move into the vehicle, clipping through whatever's needed, probably. I highly doubt it's perfect for every vehicle. So it would sit in the vehicle, and then you take control over the vehicle. But you have animations doing everything, which is why it looks realistic. That's a big thing. If you just want to teleport, then it's fine. You just use the teleport node and tell it to teleport to the destination. Like I said, it's not something I can do really simply because there's a lot of stuff in there. I want to do the secret grenade. I want to try another version of the secret grenade. We were going to try the AI version of the secret grenade because I thought that would be fun. Now it looks like this is what 8-Shot ended up going with. So for this one, we are going to drop a navigation mesh in our world. We're going to make it big. And then we're going to show it. And I don't think I have my nav mesh even close to working. Oh gosh. I have way bigger than I thought. There we go. Okay, so now our nav mesh covers basics. We'll put this up at like 500. Move it up a little bit. Let's go with 1,000. I have a feeling we have some things where our nav mesh is not going to be able to go over. They're probably too steep. Yeah, they're probably too steep for a step-up height, but that should be fine. That shouldn't be too much of an issue. Yeah, the AI version is probably so much simpler because you would just... let's see, we set this up as an actor, so technically it wouldn't work. So let's make a new... Let's do... Actually, we should be able to do this. This might work. Let's duplicate this into our Seeker Mind AI. Let's change our parent class to pawn. So that is going to be under class settings. Here we go. So we'll make this into a pawn. And now we should at least have a pawn for AI purposes. And then we should be able to get rid of like all of this code for the most part. We don't need this or this or this. We can set up AI move to, and we'll actually fill in. We'll do the location version first. Yeah, we don't even need to save our start anymore. So we'll do our end location, self. No clue if this is going to work because I don't remember if yeah, let's get rid of the other one. We don't need him in here. Let's put our Seeker Mind AI in the world. And where's our player? He's here somewhere, right? Yeah, okay. Because I don't know. I don't have anything AI. Yeah, I have no AI controller set up, so it's probably not going to work right, would be my guess. Oh, no. I also, let's see, placed in world should work. Spawned or placed. AI should work with a pawn, right? Usually I do a character, but AI should work with a pawn, right? Wonder if this is failing. Oh, ha. No, I'm getting the player. I don't know. Let's see. Let's turn this into a pawn then, because this might be causing an issue. So let's set the default to pawn. Nope. Probably have to set this as a character. Okay, so let's try remaking that then as a character, so that way we get all the stuff. Yeah, let's try that. And then, yeah. No, we should be able to do an actor, right? An actor will work with an AI, won't it? Okay, now you guys have got me curious. I could swear, not an actor, I could swear a pawn would work with AI. Let's find out, shall we? It might be a different note that works with pawn. Let's see, movement component, or your blueprint is a character. You need a nav mesh and a movement component. Let's see. I could swear a pawn would work with an AI move too. Yeah, you guys are probably right. Oh, okay, hold on. I think it is the simple move to is what I was thinking of. Okay, that might be it. Okay, let's oh, it's not gonna let me undo. Oh no, it's not gonna let me undo. I think that's what it was. Hold on a second. Bear with me. I know I can make a pawn move. I know I can do it. I know we can do it. I think it's a simple move to that was what it was. Let's see. So, okay. I don't plan on giving up on this one yet. Let's try this. Nope. Seriously? Oh, error. Okay, errors are good. Let's see. Simple move. Failed. Movement not allowed. What? Oh, do I not have collision set back up properly on this one? At least we know it tried to work. Everyone's telling me, don't do this. Yeah, I know the character will work, but I could swear I had pawn working. Simple move failed for AI controller. Movement not allowed. Why is the movement not allowed? I'm not in the... I bet you we don't have any form of collision mesh. Why do I think... I think our sphere is really stupid here. I know we can do this. I know we can do this. You know what? Let's try this. Let's make a straight pawn. Here, we'll even name it Seeker Mind Pawn. Okay. So let's try this. Sphere, and then do simple move to location. Get AI controller. I think just to get controller, right? Get controller should still work if it's not, or does it need an AI? Or no, it needs a goal. Okay, yeah, okay. I will make this work. I'm not going to give up on this thing. Definitely didn't like that. Yeah, darn it. I know there's a way to make it work because it's okay. You know what? You know what? That's what the Google's for, right? Let's see. Simple move failed. Simple move failed. AI move can fail if an AI pawn is controlled by physics, controlled by matinee, or using root motion. Bounce be caused by components. Movement not allowed. Movement not allowed. Movement not allowed. Don't have physics enabled. Okay. Trouble with simple movement AI. Movement not allowed. I don't think AI controllers. No, you can't tell me that. Nav mesh check. AI controller check. Auto possess check. Think you need to cast the controller in level AI controller. I don't think controllers have access to simple move to location. Just pull off a pin and get controller. Cast to AI controller. If it doesn't, the error disappears. Okay, well, that dude's got a dot for his name for one of the people. Okay, so let's see. Cast to AI controller. And we still get. Oh well, it was a good try. I know there's an answer to this solution. I know there's a solution to this problem. It's got something to do with the way we have our stuff set up. I really wish I could figure it out easily, but I don't really want to take too much time on this one. I have a feeling it has to do with like collision and not being able to path properly. But the nice thing is we can just ignore that. So we'll go back to our AI mine. So this is our character that's got... Actually, we can add a character movement to this, right? Oops. Oh, you can't add character movement. You can't add character movement, can you? Oh, well, that's rude. Okay, then. You can tell I do things differently, not very often. Oops, not AI move 2. So we'll go back to what I set up and deleted multiple times. Get player controller. Get control pawn. Plug him in. He should be set up to, let's do it for both. AI controller. We'll get ourselves to make sure we move ourselves. I meant to do get active location. I just want him to move. I don't want him to follow. Okay, so here's our seeker mine. We should probably put in. So you did you not use the skeletal mesh at all? I'm curious. I lost my chat. There we go. Or did you just hop in? This was just something someone was asking. It's not technically. It's like any seeker mine, I guess. CB, just trying to show different ways of doing like a basic seeker mine, and keeping it from falling through the ground. And we did a basic line trace version. Now we're doing a I don't know, what are we doing here? I don't know why I did that. I didn't need to do that. I could just add a sphere for our example. There we go. And then seeker. And then we're doing like an AI version right now is what we're trying. Because our pawn version refused to work properly because it did not like me. And then probably change our capsule, huh? I don't think our capsule needs to look quite that stupid. What we got? Probably what we're thinking 60-60? Or probably 50. Let's go 52-52, so it's a little bit bigger. Like that. Yeah, we'll go 52-52. There we go. Don't drop down the ground. In theory, yep, see, that one works perfectly fine. And it rolls over and gets to the player. So yeah, as you can see, the AI one works a lot easier in terms of code. It's much simpler, but it requires you to actually have an AI nav mesh, and it requires it to be a character or a pawn rather than the other one. And yeah, you do, like 8Shot's bringing up, you don't need to set up a hover function, or you don't need to set up something keeping it off the ground. You just adjust your capsule component. So you make it like something like that, for example. And now it'll stay off the ground even more because it uses the capsule component as the collider. So a lot less code, obviously, and worked perfectly fine. Two different ways of doing the same thing. They both work. This one, however, again, requires a nav mesh, whereas the other one technically doesn't. So you could even have it find the player in a way it wouldn't normally be able to get to because it'll use just straight movement. But they both work. What is the red square on the event begin play used for? You can drag off of it. This isn't a delegate. This is for basically for dispatchers. It's a primary use for it. If you wanted something to... what's the easiest way of doing this? I hate using these things. Okay, so you'd have things that are hooked in properly if they're called. It's a delegate. I mean, I hate explaining delegates because I personally always run into problems with delegates. Let's see, what's the easiest? Let's see. Yeah, because even then, it's not going to allow us to bind to the output. Can you? I don't think you can bind anything to the begin play one, can you? Oh, there we go. Okay. It doesn't activate stuff. Stuff activates it. So in our MMO project, we have when a player, when a monster dies, it tells everybody around it that it died. And it does that by using event dispatchers and things listening in. So when it listens in as an event dispatcher, you have to tell it what to do when something happens. So let's pull up. Why do I have two projects loaded up? Oh no, well that's the server. Never mind. Where's the epic stuff? So let me show you on this one. Yeah, I don't think begin play wants to be bound to. To answer the question about the database, I'm using MongoDB is what I'm using. Okay, so here's an example of using that little red pin. So we have okay. So here's two event dispatchers. Listen for death and listen for value changed is what these are. These are two little event dispatchers that basically can be called and things can listen to them. To listen to them, you have to basically bind yourself to them. So if I can find my player, and we can find the bind event, which is going to be on the target change. I think it's this one right here. Yeah. When you bind to them, you basically say, hey, when this event is called, so listen for value change or listen for death, I'm basically, okay. Here's my monster. My monster has two things that I can listen to. And these things can be called at any point in time. What I'm doing is saying, hey, monster, I want to listen to those things. Now, when you tell me about them, when you say, hey, this thing happened, I need to do something. And I do that by binding to the event right here. That's what the little red one is for. So I'm binding to an event. I'm saying, hey, when this is called, I want to do this. And that's what the red ones are for. So you're connecting two things together, basically. You're tying them together. And that's what the red node is for. That's the delegate node. You'd have to look into events and delegates, but it's a great way. In our instance, for example, like I said, we have value changed and death. So when the monster dies, anybody who's listening for the monster to die will know. The monster doesn't care who is listening and doesn't keep... well, it technically keeps track, but I mean, it doesn't... let's see. I don't know the right way of saying it. Delegates are not something I'm very good with. I know how to use them. I know what they're used for. I'm horrible at using them. So I'm obviously very horrible at explaining them. I wish I was better at explaining them. But our use case is, hey, the monster died. My player was listening for the monster to die. And when it died, the monster told everybody who was listening, hey, I died. And in that case, my character needs to know exactly what to do when something dies. And that's what this red thingy is for. I'm going to keep this up because we're probably going back to it. Dima. Anyone know how to import an array of transforms into a data table in UE4? Yes. That's actually the video for tomorrow. Believe it or not, because I haven't covered exporting I haven't covered exporting and I haven't covered arrays. So if you want, I can show you that. Someone's asking for a shout out, but I don't know how to pronounce his name because it's not a name. So you have a shout out. I'll go with L because that's the only letter I can make out. I'm glad you like the videos. Anyone 2D bat generation? You can ask it for all you want, but I don't know how much I'd be able to help you. I've never touched the 2D system. I barely touched the 2D system. Let's see. I was sketching back. Okay. Yeah, they definitely aren't some random square. Okay, so Dima. So let's go back to my example folder. I was actually I have to record this video today and the rest of the videos for this week. But I've got this one technically covered already. So I will quickly run through it. Actually, we're not even going to work on the live stream. It looks like we managed to do none of the live stream work today. Can I have a shout out to Max? Max would like to have a shout out. I guess you can have a shout out, Max. I appreciate you guys watching and asking questions and participating. So here's our data table map. This is the one I used over the last week for the data table stuff. And I need to pull up some files. So let's find those files at this point in time. Let's see. I need to find my data table so we can play with it. And it is hiding right here. Here we go. So let's grab this data table. So here's the data table I'm using for my example right here. Which apparently I need permission for because I don't know how to... Oh, you know what? I don't need to do that. I don't need to do that. I can do... here, let's try this. I can just do a new sheet because I can do a new sheet. Okay, can we just give me a new sheet? Oh, seriously? Google, you are not helpful at all. Okay, let's try this again. So this is the spreadsheet I will be using for my example, which you can see is full of funny stuff. Let's name it skills. Okay. So for arrays work if you think of, instead of the traditional for an array, you have like something like this. In a traditional coded language, you have the bracket, the value, and then they're comma separated. For CSV files, it is a thingy that I never remember the name of, and then the same format, and then the other thingy. So parentheses, I think they're called, I don't remember. So if you look, it's pretty much the same, except you're substituting parentheses, I'll call it, instead of a bracket. You know, I need to zoom in, don't I? Where's my zoom button? Okay, Edge, how do we zoom in? There we go. So if we look at this up here, we will see I have an array of integers right here. I have an array of integers. I actually have an array of transforms right here. No, transforms? Yeah, I think this is an array of transforms. And then I have an array of strings right here, is what I have. So there's a couple things that make this really simple. If we go and find our project, so let's find the project I literally just closed on accident. So let me reopen that. Let me close that, and then we'll go back to our launcher, and then we'll reopen this. And then I'll close my server. I'll close the other server, and I'll close the other server. There we go. And we'll find where our stuff went to. Where'd my stuff go? There we go. Okay. If we go into our data table itself, it's actually going to look pretty much identical to what you need inside your file. That's what makes it really simple. For example, here's our structure that we have in here, and here's our skill structure. So since the last time, what I added was a integer array, a transform array, and a string array. So we have 3 different arrays here. And keep in mind, a transform is technically a structure of structures. So it's actually got a bunch of stuff inside of it. The transform contains the location, rotation, and scale, and the location and rotation and scale each contain other variables. The location is 3 vectors. So it's arrays of arrays of arrays, which are technically arrays of structures of structures. Doesn't really matter for what we're doing here. But when we have it in here inside of our data table, it's actually going to show us the format we care about. So if we look at this one, for example, this is number 9. There's nothing in here. If I wanted to know what I needed for an array of integers, I could just, oh, actually this is an array of locations. There we go, array of integers. You can just add a couple things. So we could go with 5, 3, and 4. And you'll notice it takes in a 5, a 3, and a 4 with parentheses. So that's what we would want inside of our spreadsheet. Same thing with locations. Assuming I cannot sneeze everywhere. So if we hit new location right here, you'll notice that this is the I don't know, signature, I guess, of a blank location. It's going to be a parentheses to contain the entire thing, and then it has our little other symbol that I don't know the name of. That's kind of like a parentheses, but it's got a liney thingy on it. I can't zoom in on that one, so that doesn't help. Here, let's go back to here. Yeah, I can't remember what the name of that thing's called. I literally can't remember the name of what that's called. That is extremely funny. But it's got that thingy in there. And then it's got some other things such as rotation, X, Y. It's got a bunch of values. Yeah, squiggly line. Yes, my background is currently a My Little Pony background. It's a Pinkie Pie one I stole and updated. But the nice thing is, to show you how easy it is to figure something out for an array, make yourself a new structure. So let's find ourselves a structure. Which, here we go, here's a structure. And this will be like our test DT structure. And let's say this is going to be our structure for whatever it is for our game. So our game is going to contain, let's see, let's go with our game containing a Boolean, a string, then we have a array of transforms, and then we have a array of strings. So we have this, let's say, for example. So we have, you know, is alive, and tab a bunch of times, and then we'll have name. Maybe this is a character thingy, for example. And then we'll have title, and this will be, you know, airdrop locations, or yeah, we'll call it transforms, make it appropriate. And then friends. So we have the stuff we want to put in. We could do that. So we have that. Let's go ahead and make a data table out of our test structure. So blueprints, it's miscellaneous every time I forget. Data table, grab our test structure, and now we have a blank empty data table. We'll add 2 rows, if I can find the plus button, and here's 2 rows. So now our data table has 2 rows in it. And then we'll put in test data. So in this case, we have is alive, check, name, test, name, and we want to put in data so we can actually check it out inside of our file. This title, we'll add a temporary transform, and we'll add 2 friends. So friend 1 and friend 2. And we'll probably want to add a secondary transform so that way it's an actual array. And then we can do stuff like put 1s for all the data here, and then put 2s for all the data here, like that. So now we actually have data inside of our array, inside of our transform. We have a bunch of data. Close out our data table, and then export our data table out. So export it as a CSV file. We'll save it in my, I don't know, put it in my desktop. Yeah, we'll put it on my desktop. You know, actually downloads is better. Yeah, we'll name it in here. So we'll go with test. And this is our test data table. So let's see. Now we can grab that file. Let me grab the file. And I called it test CSV. And if we open it up, here is our file. So this is the file we exported out of Unreal Engine. And we can easily grab that file and we can import it into like our Google Docs. So let's do a new spreadsheet. And then we will import and we will grab ourselves a CSV file. So let's see, this is everything on my drive. So can we just upload this, make it easy? Upload, drop it onto here. Seriously, you're not gonna let me drag and drop? Really? And we'll do test. And we'll upload the file. And let's see, test, replace, detect automatically, convert numbers to data import. And it should pull it in like we expect. There we go. So we have all that data that was inside of our game. It's now actually inside of here. And you'll see this is the data that Unreal Engine is expecting because it exported it. So now you can see here, this is what our array of strings looks like inside the engine. This is what our array of transforms looks like in the engine. So this is how you could easily make a structure inside of Unreal Engine. So we made a structure, which is in here somewhere, determined what we want. This is a completely different structure. This is the one I meant. This structure, okay? So here's the structure. We filled out the structure with some test data. So I called it new data table, apparently, right here. And we pulled that data out of there into here. And now we can edit it. Now we have our template. So, we have, row 1, row 2, oh no, well, row 3, this one's going to be false. Matt, dude, he's got no transform. I'll have one friend. So we'll go with Matt as my friend because it makes it super simple. And we have more data right here. So here's our updated CSV file. And we can do the same thing we kind of did before. We'll grab our data. We will download it out. Since we know this is the good format, we'll download it out. I'm going to go ahead and I freaking seriously save. I meant to do... Edge always drives me banana nuts. So here's our test data. We can then go into Unreal Engine and we'll go ahead and actually pull that in as a real one. So we'll grab our test data, drop it into here, just like we did before, we would normally do. And now it comes in as test data, and you'll notice this now has our new information. But it's all correct. And now that we have the link set up between the way we want our data to be formatted and then our CSV file, now we can export stuff and bring it back in and continue editing. And we can throw things back and forth, back and forth. Yeah, this is the video I'll be making later today and covering, but that's the simplest way of doing it. I could have obviously gone into just, do this and type things in, but when you get into things like transforms where they're actually structures inside of arrays, it gets a little complicated because you'll notice in here we actually have a, which is super annoying to grab because it starts grabbing the other one. We actually have this right here, which is one transform. And then we have this right here, which is another transform. And then on top of that, we have the outer brackets actually holding the array itself. So it gets a little confusing for trying to set stuff up. But if you just simply create it inside of the engine first and export it out, you have a good template to edit on. That was the whole goal of that. Yeah, squiggly line. I literally don't know what that squiggly one is called. It's for JSON. I mean, you use it in JSON when you're doing objects, but I can never remember the name of it. Curly bracket, maybe? Let's see. Let's see. And how do I use this inside blueprints? Like, can you edit it with an array editor? Well, this is technically our data table is an editor. I mean, this is kind of like a spreadsheet inside of Unreal Engine. Let's see. For example, if you had a data table of characters, which had name, age... Oh, yeah, you asked another one above that. Is there a way to ask a data to call a row based on its contents? Probably not. All the data table is a chunk of fixed data. You would have to probably iterate through all of the rows and then find the data you want and return it back. Okay, in Blueprints, how do you access the data? Well, we covered that last week, but you use the these two nodes right here. The data table row node. This basically grabs a row out of a data table and gives you the information. And then the data table row names gives you all the names of the data tables and gives you all the names. Yeah, these are the two nodes for getting data out of a data table. So if you knew the name of it, then you get the data out of it. Yeah, so for your question 8 shot, a data table of characters, name, age, gender, and you wanted to get the name of a character with the age of X, yeah, you're basically going to have to go through and, you know, you'd have to, you probably have to do something like, now, of course, now that you mention this, this is a valid loop for this node, which I've been having trouble finding valid uses for. That's funny now that you mention it. You'd probably have to do something like this. And then loop through all of your rows, check all the data. So, you know, breaker struct. You know, check if such and such is equal to and equal to. And then return back your result. Yep. This is more than likely what you have to do. The funny part is I've been having trouble finding a good use for this. And of course, now that you mention it after I've done the video, this is a perfectly good use for this node. Because that's how you get all the row names for looping purposes. And Max, it's okay. The video is actually pretty much about to wrap up for the day. We're almost at 2 hours, and at this point, all the questions have been asked, and we're probably going to finish up here in a minute or two. But I do appreciate you guys hanging out and asking questions. Yeah, have a good day for you, Max. This is one reason why I like people participating in asking questions, because there are things I don't think of, because I don't use everything, obviously. There's no way of using everything or knowing everything, so the more questions people ask, the more stuff I can try to figure out. Like for example, someone on Saturday asked me about getting the arrays into the CSV file, and I'd never tried it before. I knew you could do it, I just never tried it. So that brought me to doing the export and the array stuff tomorrow. So it all works out. But on that note, I think we're going to be done for the day. I've got to do a little. I've got to do all of the. Actually, I have one video for the week. I need 3 more, so I still have to figure out the other videos. So I'm going to work on that today. But other than that, we have finished up for the day. I think, if I can find the button. Yeah, we've 1 hour and 45 minutes. I think that's a good chunk of time. It's a good place to end. All the questions have been answered. Wednesday, I will. Okay, so let's wrap up normally this way. So, appreciate everyone hanging out. You can catch me on Beam, Twitch, and YouTube. If you need to contact me, you can comment on like one of the videos. They'll show up in about an hour or 2, and you can comment on them if you want for the day. If not, just catch us during the live stream, and feel free to ask the questions. I'll try to help out as best as I can. My email contact, if needed, is inside the YouTube About channel, but try to contact either through live stream or the commenting, because I pay attention to those a lot more. Today's video will be ending. Tomorrow's video is Epic's Tuesday stream, so let's see what that is tomorrow. We are going to have some sort of live stream. Okay, so tomorrow's live stream from Epic will be... Oh, it's Ryan Bruck. Oh, cool. It'll be real-time simulation and volume modeling experiments. If anyone's been watching his stuff, someone actually asked about this earlier today, about his volumetric clouds. He will be covering stuff like that. Plugin which can paint velocity and models with volumes and things like that. So tomorrow's stream will be really cool if you're into nifty art stuff. And if not... My next stream will be on Wednesday around 10 o'clock Pacific. It's roughly 1 hour and 45 minutes before now. I'm thinking we'll try to cover 416 stuff plus normal questions. Dima is asking idea for next stream. How do you set up client server replication? How to set client server relation with external solution? Do you have a little more information, Dima, on that one? I do, because like for example, for the live stream stuff we're doing, I'm using VA REST to connect to a Node.js server, and I'm using a Node.js server to store our stuff in a MongoDB. We are still just learning that. That's why I haven't actually done any videos. We're basically going to work through the entire live stream project. Someone did ask earlier, I think I remember seeing it scroll by quickly, if it was going to be a completed project. No, this live stream project for the MMO is just to actually learn a complete slice or complete vertical slice of a MMO with persistent data, with networking, with all of the stuff that you would expect for learning a complete networked game solution. So it's got a learning experience. After that, once we get that done, I plan on actually working on my own project separately, which will be kind of like an MMO. But that's months off and not even an issue. But the whole point is so we can learn this stuff so we can understand replication properly. Because I've only been doing networking for probably 3 months at this point, and it's still got some issues in my head. I don't feel confident enough to confidently pass that information along to anyone else yet. So it's still going to be basically the entire project before I actually do any videos on actual networking and things like that. This is all learning for that. But yes, client-server relation with an external server solution. Technically, I kind of have that right now, but I won't be doing anything on it yet. The best bet would be watching our live streams and watching all the pain and suffering as we've tried to set up stuff. Or just asking questions, and I can try to pass along what we've learned so far. That's the other thing to do, too. On that note, we will go ahead and wrap this up. I appreciate everyone hanging out. Everyone have a good rest of their day. The stream will basically mute for about 30 seconds, so it just doesn't disappear. It'll take, again, a few hours before it shows up if anyone wants to watch it again on YouTube. It'll be up fairly quickly on Beam or Twitch if anyone wants it. And with that, everyone else, again, have a good rest of their day.